Hey guys, welcome to the third session of Compose Camp. And today we'll be covering a few topics that are navigation, so splash screens, simple animations, how to adjust your UI, and lazy grid. So let me start off with Android Studio. So this. So for navigation, so the first point that you have to remember is that it's not included directly automatically when you are creating a project like a empty Jetpack Compose activity. You'll need to add it in your dependencies. And last time we also added a dependency for I remember constrained layouts. The last session we ended on constrained layouts, and for that we also added dependency that we do in the Gradle script section in our Android basically manifest. So this is build.gradle, and we'll go to this module, module one, the second build.gradle. And if you scroll down, there would be your dependencies block. And inside that, we'll have to add a dependency. That's this line that we added for this implementation, and then the uh, Android X dot navigation. So this will be provided to you guys in the PPT, and of course, you can add it to your build.gradle and start working on it. So in our main.kt, I'll just go and so for this I have separately created a Kotlin file where it is. And in this, so what you have to do is the most important thing is to create a navigation host. And what navigation host will take is a navigation controller and a destination. So we want to firstly give parameter, so where the navigation is going to start. So there would be a main page, and then there be subsequent pages. So for this I've created two pages. One is the main page, from where there is a button. I'll just, I think, run for you guys and then explain. 1 second. So what our example is, it's just a first screen, that is the main screen, and then there's a simple text that to show this is the main screen, and there's a button. Once we click it to there, we go to the next screen. Now how do we do this? Is firstly we have created a composable function called navigation. Inside of that, we have created a variable that is navigation controller, which is going to be used in navigation host. So inside navigation host, we have created two pages, the composable functions. Inside of that, there are two pages. So the first composable function has the main screen page, and the second composable function has a second page. So for this, yeah, and the parameter that it takes is the main screen is going to take a navigation controller as parameter, and the second screen is just taking a string. That's, I think, that's not necessary. I've used this for this example. You can also remove it. What example I wanted to show you guys next was supposed to be to how to retrieve data from main page and then send it to the second page, and use the data from the main page and implement or two functions on that on the second page. So that's why I took a string. But so what this is gonna do is we have just, so these two functions are the composable functions for the respective pages. What the page is gonna be shown once we navigate to that. That's the thing. And so this main screen has a text, a spacer for space between the text and the button. So button has a text, and the button on click will have a function that is navigate to the second screen. And we do that by using the navigation controller, and this is the function dot navigate, and in the parameter we give which screen we want to switch it to. And the strings, so this, yeah, We just gave it a function. And now you must be wondering where this screen is from. So this screen is from a, we have created a separate class. This is optional, but it's the most common it's a common practice when you'll be making an app. So we have created another class, sealed class. So sealed class is a type of class in Kotlin, uh, which is basically used to you can easily make sorry, yeah, so it's a type of class where you can easily make objects of that type. And so we have created an object of screen type only, the class itself. So yeah, and the major important of sealed is that it's protected from the outside Kotlin files. So this sealed class can only be used in this directory. It's kind of like a protected class, if you must say. So yeah, it's optional. You can also pass in a string. Uh, Basically, what this line is doing is fetching a string. So the dot navigation, the dot navigate function takes a string as parameter, and we are fetching that string from this class. You can add multiple screens. So it's just a way to organize your multiple screens. It's not a compulsion, but it's just a common practice. So you can so if you're wondering how to just separately make a class in this, so in Android Studio just right click and add new, and there'll be an option of adding a Kotlin. You can add class, file, sealed class, enum class, data class, so whatever you want. So yeah, so the function of this screen.kt was just to store and fetch our strings, the names of our screens, to help us navigate. So yeah, that's what we have done. And yeah, so just to conclude, you'll have to make a navigation host, and for that you need a navigation controller. And this you must have remembered. This is a state. Remember keywords for the state of the navigation controller. So initialize, so the first value does not get overridden. And this is the inbuilt state for navigation. And yeah, so then we can add in the navigation host, we can add the multiple pages that we want to add. And this can be also separately created. I've just, since it was a basic example, added the pages in this page only. And yeah, so and yeah, we call that second Kotlin file uh, yeah, in our main activity to run it. So another thing, since we had just done navigation, so the next topic that I can easily teach you guys is splash screen. So if you must have used any app, most of the apps have this page where it will show you its logo, and it will show you its logo, and it will take like 1 to probably like 5 milliseconds or whatever time delay, and then it's gonna run the app. So the idea behind that is to usually do some function. So that function could be to get login details, or to check if the user is already logged in or not. There are multiple things that you can do, and that's why splash screens are important. We are just going to see how it's implemented, but the functions that it can do within that delay, it's up to you. You can just make a splash screen just because it looks good, but mostly it's used to do a background function. Yeah, that I've discussed. Common one is most of the time it's getting login info, key users, and even if it's logged in, there are imagine I tell you, if Let's see, you can use Instagram too. Instagram also has splash screen, I guess. Logo in the middle, and I think by Meta in the bottom, and then it's gonna load your app in milliseconds, some milliseconds. So yeah, for splash screen, what we have done, I have created a separate function for that. So if you yeah, if you could relate to what we just did in the last example, we navigated via click of a button. We set up two pages, and the first page had a button, and with that, we navigated to the second page. So, what this time we know that we need a page, a starting page, which will have our logo and background, whatever you want. And after a certain delay and some function, it should navigate to our main screen, our main home page. So again, we this part we have done, and we have made a navigation host with a navigation controller as parameter. The host is going to take navigation controller as parameter, and the start destination is going to be. So remember in this example, uh, this is what I did now. Screen dot main screen dot root. So this was done. That's what I was telling ki you can also add the string directly. So this would be replaced by this string main underscore screen. There's no compulsion with that. It was just a good practice, so that's why I showed it to you guys. But you can easily add a string here, no problem. And so we again made two composable functions. Inside we have two pages. So there is this splash screen, and then there is composer. So what splash screen page will do is call the splash screen function. That's a composable. This is the page content. So what this does is takes a parameter, because this is the page where we have to use the navigation bit. And this launch effect is basically used to directly apply the function when the page is just launched, and it's going to take a key, and we'll give it as true to run that function. And the second function used here now is delay. So we have given a 300 millisecond delay, so that's 3 seconds. And then nav controller will be used to navigate to our second page. So it's going to take the route. So yeah, here we would have taken the this one, uh, the whole fetching the name from the class. Here we have just hard coded the string name, and that's what I wanted to show. You can directly use the string, and then there'll be a box which will have our image. And so adding an image, I think we did last time. You have to add your image to the res folder. Inside the res folder there's drawable, so inside drawable you can add your image, and the image will be located by painter resource, which is given by painter. And this is just a content description. So if we were to run this, and yeah, I'll show you one more thing that mm, 1 second, I'll show you the code. One more thing I wanted to talk about is this. So we have used oh, yeah, okay, yeah. So in this example, we have used surface. So surface is used usually when you have to do stuff with the screen's background, add a border to the whole screen, or change its background. So that's why surface is used. It's gonna implement for the whole screen. It's gonna work. So it's gonna load up our app. So, yes. Yeah. So here's our app. So it took 3 seconds for the splash screen. So we added our logo in the box in the splash screen. We sent its location here, and if I'll just run it again, stop it, I'll run again. Just close this simulator. 1 second. I think yeah, I tried. The Gradle was installing. I pressed it too many times. 1 second. Yeah, it's gonna load. Yeah, it takes bunch of time to load stuff, Gradle and everything. Yeah. So this is our splash screen. The image in the middle, and that was contained in the box. And this launch effect function took the delay, and then so here you can imagine I could make a function where I could check the login details and whatever and whatnot. So that's open to many creative things. So this is covered. So yeah, another topic that I want to discuss was simple animations. Uh, yeah, so we'll just yeah. So animations. What we'll do is we'll animate the size of an element. First animation that we'll do is I'll show you what we'll do, and then discuss how it's done. So if I click this, it should give you an animation and it should increase the size. And you must be wondering what's the difference without animation. I'll show you. I'll just show you once with animation and see the difference. I'll show you with this is without animation. Let's run it again. Yeah, it takes a long time to compile. So yeah, you can see it's like not smooth at all. It's just gonna increase the size without animation. So I'm gonna do this, and yeah. So what we have done in this case is we have created a mutable object that is without without animation is just to remember the size. So in the starting, use the 169.dp as size, and what we have done is we have created another animation. So basically, this is also a mutable object. So we had done this mutable for mutable. We had done this remember easy val variable name equal to remember, but this is another method where you can create a mutable variable is by using the keyword by, and it's the same syntax just without equal to. And what we have done is we have created another variable which is basically animate dp is by compose, and we have it takes two parameters. One is the initial size, the target value, and the other is a function for the animation. What we have done is use the tween function. There are also other functions that I'll show you. One more two functions that we'll discuss. Two more functions. The tween function will basically take the delay in how much delay do you want to increase the size. That's why it's doing smoothly. It's gonna take 1.6 1.069 seconds, and then it's gonna increase the size. That's the delay. So what we had done is we had made a box, and its size was set to this variable. And this takes the initial value as 169 dp, and then we did the background color, and so the box has a button which on click will increase the size, the initial size, the target value, so this value. And yeah, so we'll increase that with 50 dp, and that's the simple text for the button. So yeah, so this takes the animate dp as state will take two parameters. One is the initial value, and the second is the function that you want to implement with the animation. So if we remove this one, uh, and we'll apply, yeah, we'll apply more things to this. I'll show you one more thing. Hmm, there it is. Where's the, yeah, here it is. So in this, yeah, I did. One second. Yeah, there are two more parameters that we could discuss. Or this was delay. We could also do, yeah, duration milliseconds. That we could do 4200, and easing. Easing is, I'll show you. You'll understand once I run it. I'll just disconnect this app. I'll just, one second, if just change the emulator. Hmm. So yeah, what we have done is we have given a delay, a duration, and easing. Linear easing would be how fast, with what ease the size is going to increase. So duration is that it's going to take 4.2 seconds to complete that animation, and delays for the next click, it should take at least 1.069 seconds to do the next animation. So if I do this, it's going to take longer. It's going to take 4.2 seconds to complete the animation, to complete the 50 plus dp size. And we could also change, but we could, if 200 though, you wouldn't even notice the, yeah, so 200 is faster. And yeah, that's about the tween function. There's also a spring function which will give you a bouncy effect. Some people like it bouncy. So for that, you can give a high bouncy effect. And yeah, we'll just, if it's gonna, yeah, after we run, I'll just stop all. One second. It's our previous. Hmm. So what this did it is gave a bouncy effect every time we increase the size. So this was basically triggered while we use the button. What if we wanna have a animation throughout our run? So what we can do is create a infinite, uh, basically, it's gonna repeat till infinity. And what we're gonna use is create a infinite transition state variable. And we have create what we're gonna do is gonna change this box color throughout its run. So what we did is create a infinite transition mutable object, and in that we used dot animate function. What this took was the initial color, what we want to achieve, what color should be changed, and then it's gonna take the animation. What animation do you want? Do you want a delay in it? And and what so this for the color change we'll give a, for duration we used the tween function last time. So we're going to repeat that. We'll use the tween function to give it a duration that it should take 2.64 seconds to complete this transition. And second thing is the repeat mode. So after it's what this means is what to do after it changes the color from light gray to yellow, what to do after that. And with repeat mode we'll say just repeat what I said. We can do reverse. So what this will do is then do yellow to light gray, and then it will repeat the process. And it will be light gray to yellow, yellow to light gray. That's why I used repeat mode. So if I run this is the older version. Yeah, I'll just change this to 1 second. Background, I'll give instead of keeping it constant, I'll use this variable, the color variable. Just run it again. Yeah. So we didn't click any buttons and still it started the animation. That's the thing. So we can do this. It's still gonna do the bouncy effect because we defined that in the for the box. And yeah, so that's about the color animation and size animation. And yep, we did. mm, yeah. So yeah, two things are left. One is screen size and lazy grid. Let's discuss lazy grid first. So we did, if you guys remember, last time what we did is we created lazy grids and rows and columns. So basically, we discussed why it was better. We also did rows and columns. Why lazy rows and columns? And the answer was that it was more optimized for more number of items. So if you make a row or a column scrollable, what it did was that during runtime it used to render everything, and what lazy does is it's gonna only render those items that are visible to the list, visible to the screen. And when you scroll up or down, the elements that are needed to be shown will be uh, then loaded, and rest of them won't be loaded at that time. So this is a, by as the name suggests, this is a grid, and inside of the grid it's gonna take two things. One is the cell. So cell basically it's saying that it should fill vertically 100 dp, as many items 100 dp can fill them. and content will take what to display inside that grid. So we also did items, we used items in our rows, lazy rows and columns. Yeah, this code we did last time. Hello daddy, hello mommy, yeah, this one. So that's in the last session, you can see the recording of that. uh, yeah, so what we did is then we created a box, and inside the box we gave some modifier attributes. We gave it padding, we gave so aspect ratio. What we'll do is we'll make it so there are different aspect ratios, 1:1. So 1:9:16. Your phone is 9:16. Your sorry, the full portrait mode is 9:16, and 1f would mean that it's a square. It's a 1x1 or 3x3, whatever. It's a square. What this means is, and we used clip to basically give it a round corner. The corner should be rounded, and gave it a background color, and align the content center. And so, what items does it? It takes a count, and that count can be used. So I think last this functionality we have discussed. So if we didn't do, I'll show you what output will be first, and we'll take this I. This is the basically index. So it's gonna start from 0 to 690. So it's gonna finish at. Unfortunately, it will sense it from 0. So yeah, 690 won't be printed. So then I should do this, I guess, to make it, yeah. Since it's gonna start from 0, it's the issue. Or I could have done is I plus 1, whatever you want to apply. Just want to see this. Cool. So we can also increase it to like thousands. So, and the reason it's very optimized is that till now it's only gonna load this section, and that's why we use lazy functionalities. If there are more items, if there are like 5 items or 10 items, then just make a row or column and make it scrollable. It's not gonna make much of a difference. But this is just for optimizing for large content. And yeah, so hmm, s- so I think it's done. And last thing I want to discuss is uh, how this will, let me rotate this, right? Yeah. Okay. No, I forgot the. Yeah, I could rotate the. I think the screen you could rotate. Uh, second, if I could. Mm, so don't worry. Yeah, no worries. So last topic that I want to discuss was how to make it adaptive. So imagine if I just rotate the screen, and how it would look on a tablet or a TV, it would be different. And the most common practice for that is to make different layouts, is to make how it's gonna look in a compact device, in a phone, in a tablet, or in a TV. Or so basically, it's just a standard number that we take. So this is the bit, yeah. So it says like if the screen width is less than 600 dp and the height is less than 480 dp, then the screen, we can call it a compact, it's a phone. And if it's like less than 840 dp, the width is less than 840 dp and the height is less than 900, then it is a like a tablet. And if it's greater, then it's a bigger device. So what approach we do to tackle the problem of working with different sizes, screen sizes, is we create the composable function, and inside that we create a class. So this the goal of this file is to retrieve a a window size, a height and a width. Get the screen's width and height, and then in your main function, what you'll do is fetch the window information and then use if else. So if the window info is compact, then let's say apply this. If if else the size is that, then make we have to make changes. we had we have to, if it's like a, because it's a tablet, then if you rotate it, for this example, so it could have fit like uh, 0 1 2 3 4 5 6 in one row, but that's the difference in layout. So we could have adapted to tablet. That's how we adapt to different sizes. We make three different layouts. We fetch information from our another. You can do it in this Kotlin file too, but it will get too messy. That's why I created another Kotlin file. And when once you retrieve, make three layouts and then call whichever is your size. So to discuss this, first we'll make a class, data class, and we'll take the class will have four variables. It will have a screen width information, height information, and a screen width and height. So the screen width and height will take the measurements in dp, and inside of the class we'll have another class to basically label uh, uh, three categories: compact, medium, and expanded. And inside the function, we'll use local configuration uh, class, and which has a function current, so which will give us a variable configuration. And with that we can retrieve the screen width in dp and screen height in dp. So this function gets, so if you remember from the first session, when is the equivalent of switch case. So if you guys must have done another, if you guys would have done Java or C, anything, what switch case is, or in this case, what when is, we make different cases of a variable. If the configuration dot uh, screen dp is less than 600, is basically, so then we use our separator and we return the compact screen. And similarly there are three cases. So yeah, and the else case is gonna go when these two cases are false. And similarly we made this for height, and then we set the screen width and height. This is gonna help us retrieve kind of a, to identify which category to put in, and these two are to retrieve the value, what the actual value is. And so yeah, you will have to, once you are in the main file, just make three if else statements and work accordingly. I think that sums it up. And what else I want to say was, so we have discussed most of the topics, that I think almost all topics that are present in the first four units. I'll confirm it since I took a overview of it. I didn't see each code lab, but I saw the topics, and I think most of them have been discussed. So I'm sure you can complete the first four tracks with the information till now. And what you should also do is start working on the app that you have to submit. So I'll give you three phases for you to work on. First would be to just think of a simple idea that you will be able to implement. Second would be to design your app on a software most easiest to learn, easiest and fastest to learn is Figma. You can just easily type in Google on YouTube. You can get a 1 hour tutorial. I think maximum it will take you 1 hour. And if you're like me, you can retrieve like comprehend information in 2x. That's best. Figma is just mostly drag and drop, but it has so many features and so many functionalities that it's just easier. Just take a look at a YouTube video for it, and it won't take you more than an hour to learn it. And try to design the UI in Figma. And once you have done that, just then what I had done till now was teach you how components work individually. I either created separate functions or, but I haven't, compiled. We have done so it's like 452 lines of code, and uh, only this much is running to output this. So yeah, that's why we haven't compiled everything yet to make a full-fledged app, so that we could start in the next session, or we could start. Yeah, we could also cover more topics that are not included in our units that would be beneficial for you to build the app. The next session would also be kind of like this, 7:30 next Friday, and I have midsems. So for with the following week, I think from 26th of September. So I wanted to postpone that, but yeah, it's too late now. So no worries. We'll either we could start building a simple app, or we could do more components for you to build the app. So the major reason I wanted to let tell you guys to build your UI on Figma was just to get the idea of what the page will have. It will have a row, it will have a column, it will have these many text labels, it will have these many uh, buttons, text fields, how many pages will it have. So that sort of stuff will very easily get in your head. What all do you want to add in your layout? That's the thing. And 1 second. So yeah, um, so this was the end of the third session, and I hope you guys learned enough. And for the next session, yeah, I've told you we'll decide on the syllabus. I'll let you guys know. Would be on 23rd, same 7:30, and I hope you guys to meet there online. So yeah, bye bye.